All right, so I'm going to go ahead and work on questions 5 and 6 now. They say, evaluate the integral using the integration by parts formula given the choice of u and v prime. So if you notice 5 and 6, they give us both indefinite integrals, and they already tell us what u and v prime are. So the only thing I need to really worry about is what's the rest of the information that I need for this integration by parts formula. Well, so the first thing I'm going to do is write down what the integration by parts formula is. I'm going to do that over here. So the integration by parts formula goes a little something like this. So if I have an integral of u times v prime, I can simplify that as u times v minus the integral of u prime times v. Now, usually these are in terms of x or some other variable, so these u and v substitutions just happen to take place of what other variable I'm using. So in this case, I'm using x. Now, in number 5, we've got the indefinite integral of 2x plus 9 quantity times e to the x dx, where our u is going to be 2x plus 9 and our v prime is e to the x. So notice in the formula I've got u, I've got v prime. What I still need is I need a regular v and I need a u prime. So I'm going to take the derivative of this u, so u prime, and the derivative of 2x is just 2. The derivative of 9 turns into 0, so this is just going to be 2 dx. Now, I always like to write my dx so I remember what variable I'm using. And this v prime, I'll stick a dx on the end of it. In order to get v, we're going to integrate that e to the x dx, and which, nice thing about e to the x is it's just e to the x. So, again, I'm going to come back over here to this formula, and I'm going to think about it and say, okay, so I had u, which is 2x plus 9. I had v prime, which is e to the x dx. And all I've got to do is switch it out for u times v. So u, which is 2x plus 9, times v, which is this e to the x. Then I'm going to subtract this integral of u prime, which we wrote as 2 dx, times v, which is e to the x. All right, now that I've got that written down, hopefully you guys recognize this 2 that's inside this integral can kind of come out. So I'm going to have 2x plus 9 e to the x minus 2 times the integral of e to the x dx. And we already talked about this earlier. The integral of e to the x dx is just e to the x. So I'm going to write this down as 2x plus 9 times e to the x minus 2 times e to the x. Hopefully you guys think about this for a little bit and say, oh, I should probably go ahead and distribute this e to the x to the 2x plus 9. So I'll write it as 2x times e to the x plus 9 times e to the x minus 2 times e to the x. And the reason I did that is because, oh, look, I can combine these like terms. And so that's going to be part of my final answer. And I'll just go ahead and write it over here on the blank. It is 2x e to the x plus, now if I do 9 e to the x minus 2 e to the x, that's going to be 7 e to the x. And the only thing that I need to remember is, as part of my final answer, I need to put in this plus c. Remember, we had an indefinite integral, so I need to remember to put in my constant of integration. Okay, that's the important thing to remember at the end of those. Now, I'm going to go ahead and start looking at number 6. Number 6 says the inverse tangent of x dx, where u is inverse tangent of x, and v prime is 1. And like I said, I always like to put dx at the end of my derivatives just so I remember that we were, again, in terms of the variable x. Now, again, make sure you remember this formula up here. It is a very important formula. I'm going to need it for all of these problems. So now that I've got that written down, I'm going to come back over here and again say, okay, so I've got u. That's the tan inverse of x. And in this case, my v prime is just this 1 dx here at the end. So I need to think, what's the derivative of inverse tangent? Now, that's a formula hopefully you guys remember from a while back. It is an important formula to have just on the top of your head. In case you have forgotten, it is 1 over x squared plus 1 dx. This v prime, which is 1 dx, I need to integrate. Well, if I take the integral of 1 dx, that's why, again, I needed that dx at the end, is this is actually just going to turn into x. Okay, so that was, again, an important thing to think about is what variable am I doing this stuff in? Now that I've got that taken care of, again, I'm going to come back up here to my formula and say, hey, what things do I need to write down? So if I've got the integral of inverse tangent of x dx, this is going to turn into u times v. So inverse tangent of x times x. I'll write it down. Inverse tangent of x times x. Now, in my next step, I'm going to move that x out front so I don't get myself confused and write x squared here at the end. And then I'm going to do minus the integral of u prime times v. Well, in this case, u prime we said was 1 over x squared plus 1. I'll put my dx at the end. Times v up here, which is just x. And I'm also going to go ahead in this step and go ahead and multiply 1 times x. And you'll see why that's helpful in just a second. So we've got tan inverse of x times x, which I said I was going to write as x times tan inverse of x. Just move the x out front. And I'm going to write minus the integral of x over x squared plus 1 dx. Now, hopefully you guys are looking at this integral and saying, man, that's not as easy as that e to the x was up there. But it's still not as difficult as another integration by parts. Now, there are some problems where you have to do integration by parts a couple of times. But in this question, I don't. In this question, this is actually a u substitution. And hopefully you guys picked up on that by saying u is going to be that x squared plus 1 that's in the denominator. And if I take the derivative of that, the du is going to be 2x dx. So all I have to really think about is, hey, wait a second, what am I going to do with that 2? So what I would do is I would write it as 1/2 of du equals x dx. Now I've got the x and the dx. I've got the u in the bottom. So all I have to remember is to put a 1/2 out front of that integral. So I'm going to go ahead and write that down. So we'll write as x tan inverse of x minus 1/2 of the integral of 1 over u, which was that x squared plus 1 du. All right. Now, hopefully you guys remember that the integral of 1 over u du turns into a natural logarithm. I'll go ahead and write that down here. So I'm going to have x tan inverse of x minus 1/2, the natural logarithm. And we always use absolute values around that u. Or we always use absolute values in general when we're trying to do that natural logarithm integral. The other thing I want to point out to you is I still need to remember to switch that u back from my x squared plus 1. Now, in this case, I don't really need to use absolute values in my final answer. And the reason I don't is because x squared plus 1 is going to always be positive. X squared, take a negative, square it, it's going to become positive. Take a positive, square it, it's going to become positive. And then you're going to add 1 to it, which makes it even more positive. So I don't really need the absolute values in my final answer. I'm not going to take off points if you write it. But here's the thing. I'd rather you write the absolute values and not actually need it than need the absolute values and not actually have it. So that's, again, the thing to think about here is I'm not going to need the absolute values, so I'm probably not even going to write them. So let me go ahead and write down what my final answer is going to look like. So we've got x times tan inverse of x. Then we've got minus 1/2 of the natural logarithm of my u, which was x squared plus 1. And again, this was an indefinite integral, so I need to have my constant of integration at the end, plus c. All right, so I'm going to come back and do the last couple of problems in just a second.